In this lecture, we will be discussing about hardness of water. So when we say a water as a hard and when we say a water as a soft, so we define soft water, a water that produces lather with soap, produces lather with soap. So this is a definition of hard or soft water. Now what is hard water then? A water that does not produces lather with soap. So does not produces lather with soap. Now what is soap? So soap basically contains C17H35 COO minus Na plus. So this is a part of soap. So this is one component of soap. Now why water becomes hard? So we'll discuss. So water becomes hard because it contains a multivalent cation. So water becomes hard. Water becomes hard due to multivalent cations. And this cation can be Mg2 plus, this cation can be Ca2 plus, this cation can be Al3 plus or Fe3 plus, that is more than 1 plus charge. In all cases you have more than 1 plus charge. When we add soap in a water that contains, let us say, Ca2 plus, so I have a water that contains Ca2 plus and I am adding soap, that is this part C17H35 COO minus Na plus. Now it first forms an insoluble salt. So if I take 2 molecules of this balances the charge. So you will have Ca2 plus and this is C17H35 COO. So it balances the charge and it forms insoluble salt. So this is insoluble and you will have 2Na plus. Similarly, if you take magnesium, you will have Mg2 plus. This again forms insoluble salt. So this is Mg. This forms again insoluble salt, 2Na plus. So what is happening? This is a part of soap that has to remove the dirt, but now this part of the soap is combining with Ca2 plus. That is vestige of soap. So this is just a vestige of soap. Vestige of soap. If we add excess soap, what will happen? All Ca2 plus will combine with soap, and then after we add more soap, this will start acting. It will start functioning. So if we add soap in excess, initially it will form insoluble salt, but later it will start functioning. So we discuss why water becomes hard. So water contains Ca2 plus, it can contain Mg2 plus. Generally for our purpose we will discuss only Ca2 plus and Mg2 plus. Now if water is neutral, apart from this cation, so this is cation, water must have anions. Generally an anion present in the water is SO4 2 minus, Cl minus, HCO3 minus and CO3 2 minus. So this water has to be electrically neutral, so water is electrically neutral. So it has to some anion is present. So these are the common anion present in water. So these are the common anion present in water. We also have phosphate anion present in water. There are some more anion that is also present in water, but we are leaving those. Now on the basis of anion, basically cause of hardness is cation. So this is the cause. But we divide hardness of water in two categories on the basis of anion. So on the basis of anion present in the water, on the basis of anion present in water, we divide hard water in two categories. And first we call this as a temporary hardness. So first we call this as a temporary hardness. And the second we call this as a permanent hardness. Now let us discuss first temporary hardness. And temporary hardness, it is due to the bicarbonates, that is HCO3 minus of Ca2 plus and Mg2 plus. You can have any multivalent cation, but for our purpose we are only discussing Ca2 plus and Mg2 plus. So this means if my water contains calcium bicarbonate, water is temporarily hard. If it contains MgHCO3 or twice, water is temporarily hard. That is a cause of temporary hardness. Now we can remove the temporary hardness. So removal of temporary hardness. So we are discussing what are the ways by which we can remove temporary hardness. That is removal of temporary hardness. And the first way is by heating or by boiling. By heating or boiling. So if we have water that is basically temporarily hard, let us say calcium bicarbonate, and if we heat, these bicarbonates basically dissociate and gives you carbonate. So you will have CaCO3 plus H2O plus CO2. Now this CaCO3 is basically insoluble salt that gets precipitated, insoluble. So you see we have removed this Ca2 plus in form of insoluble salt. So this is a way to remove temporary hardness. Similarly, if I have magnesium bicarbonate, that is MgHCO3, and if I heat magnesium bicarbonate, it will form magnesium carbonate. Once again this is insoluble, and you will have H2O plus CO2. So one way to remove the temporary hardness is by heating. Another way we have, that is by adding calcium hydroxide, or it's called slaked lime. So slaked lime. So we can add slaked lime, that is calcium hydroxide, to remove this temporary hardness. Let us say I have calcium bicarbonate and we add calcium hydroxide. So this time this is acting as an acid because HCO3 minus can give H plus, and this is acting as a base. So this is simply an acid base reaction. You will have, it will take 2H plus, so you will have 2H2O plus CaCO3. So CaCO3 2 times, because here also I have plus 2H2O. So this is one way to remove the temporary hardness by adding slaked lime. Another important point in this case, if we add COH whole twice in excess, what will happen? It will initially react with calcium bicarbonate, but excess will remain into the water, and excess will itself cause, excess HCl2 plus itself cause the temporary hardness or hardness in the water, because if we add excess amount of CaOH whole twice, that is calcium hydroxide, initially it will react with calcium bicarbonate, but later it will itself cause a hardness. So we can say a calculated amount of a calculated amount of calcium hydroxide should be added in hard water. Otherwise, it will itself cause a hardness. It will itself, that is excess, itself cause a hardness. That is whatever excess we have, so excess calcium hydroxide, whatever we have, that will cause hardness. So basically how we will calculate how much I have to add, and that can be performed by EDTA titration. So calculated amount can be known by the EDTA titration, that we will not discuss here. Calculated amount can be known, or required amount can be known by EDTA titration, and this we will discuss sometime later. Now we have discussed two methods. If water is hard, we can remove temporary hard, we can remove by boiling, or we can remove by adding calcium hydroxide. We can also add calcium oxide, that is by adding CaO, that is called quicklime. If we add CaO, it can also remove the hard water hardness, temporary hardness, because when we add CaO in water, it initially forms calcium hydroxide. So now the same is adding calcium hydroxide. So adding calcium hydroxide or CaO, both will remove the temporary hardness of water. Now let us discuss permanent hardness of water. So what is the meaning of permanent hardness? When my water contains SO4 2 minus, Cl minus, CO3 2 minus, so hardness due to the CO3 2 minus, SO4 2 minus, Cl minus, we'll call this as a permanent hardness. So if I have CaSO4, let us say this is a cause of permanent hardness. If I have MgCl2, this is a cause of permanent hardness. Similarly, we can have MgCO3, this is a case of permanent hardness. Now permanent hardness cannot be removed by boiling or adding calcium hydroxide. So important point, permanent hardness cannot be removed by adding calcium hydroxide or by boiling water. So how we remove calcium, this permanent hardness? So removal of permanent hardness is generally done by adding baking soda. So removal of permanent hardness. So this is done by adding baking soda. So first is by adding baking soda. And baking soda is nothing but Na2CO3. So if we add Na2CO3, we can remove the permanent hardness. Let us say if I have permanent hard water, CaCl2 it contains, plus if we add washing soda, that is Na2CO3, it will form CaCO3 plus NaCl. Now CaCO3 is solid, that will basically precipitate, so it can remove Ca2 plus. So we can add washing soda. Similarly, we can have CaSO4 plus Na2CO3. We will have CaCO3. This is again solid, it will precipitate and will form Na2SO4. So we have removed this permanent hardness by adding washing soda. Another important point, washing soda will also remove the temporary hardness. Will also remove the temporary hardness. So let us say water contains calcium bicarbonate, and if we add Na2CO3, it will form CaCO3 plus twice NaHCO3. So you see, we have removed Ca2 plus because Ca2 plus is forming a precipitate, insoluble solid. So washing soda will remove permanent hardness as well as temporary hardness. Let us say we can find percent. There is one more method by which we can remove the permanent hardness, that is by ion exchange. So let us discuss here itself. By ion exchange. So permanent hardness can also be removed by ion exchange method. What this ion exchange method? This basically consists two chamber. Let us say this is one chamber we have. And there is another chamber. One is called cationic chamber or cationic exchanger. So that is, first is, let us say, cation exchanger. And the second is called anion exchanger. What we do, so this impure water, impure, or you can say hard water basically. So this impure, this means hard. Water enters into this cationic chamber, and now then after this it enters into the anionic chamber, and finally we have, this is pure water. And here I have, this is anything that is impurities that goes out. So that is waste material. So let us discuss what happens here. Now this cationic exchanger basically has granules, something of insoluble organic acid resin. So these granules basically contains molecules. So I can say cation exchanger consists of granular, insoluble, organic acid resin, organic acid resin having giant molecule with SO3H group or COH group attached. So what is the meaning? We want to say this basically contains, so these are the granules. These granules contains a giant molecule, so big molecule I have, and the end part of this molecule contains either acidic group COOH or it may contains SO3H. So what we can do, we can write this molecule as RH. So this part I am writing R and this is H. So I am writing this giant molecule as RH and this is again RH. And this molecule is basically fixed on a granule. So you have a granule kind of thing and this molecule is basically is fixed with this granule. So this is this kind of thing. So RH, RH. And now this is H is positive, negative. So if some anion comes, what will happen? H plus can be removed and some, let us say I have a Ca2 plus. What will happen? If I add Ca2 plus, one molecule, one atom of Ca2 plus, these two H plus will be removed. So I have here H, H, H. And these two Ca plus, these two H will be removed and in H plus we will have Ca2 plus. Now these two part of the molecule gets joined by Ca2 plus. This means Ca2 plus get trapped. So if my impure water contains Ca2 plus, when we pass through this cationic exchanger, Ca2 plus gets trapped inside this exchanger and in place of Ca2 plus this water will contains H plus. So we can write equation. So if I write this as a RH and let us say my hard water contains Ca2 plus. So if I pass through the cation exchanger, H will be removed. So we will have 2R or I can say R2Ca2 plus and 2H plus will be freed. 2H plus will be freed. So another important point, when this water that is coming through this cationic exchanger is basically acidic in nature. So water that is coming out from the cation exchanger is acidic in nature, that is it will have H plus. So to remove this acidity nature, what we do, we have an anion exchanger and this anion exchanger is basically basic in nature. So this anion exchanger basically contains, so what we have in case of anionic exchanger, the same thing, you have a granules and these granules this time gets attached by OH. So in place of H we have OH. So this has OH. So every place you have OH, OH, OH. Now we can write a condensed formula of these granules is RNH3OH. Now when this water passes through this, now hard water contains Cl minus SO4 2 minus. So what happens, this RNH3OH and Cl minus, so Cl minus gets exchanged by the OH minus. So we will have RNH3Cl plus OH minus. So Cl minus gets exchanged by the OH minus. So we can say anion gets exchanged by OH minus. So idea, you see, when we exchange OH minus, now water becomes basic. Initially it was acidic, that it contains H plus, now it contains OH minus. This means finally water becomes electrically neutral, that is a neither acidic neither basic. So this is neutral water. So pure water that is coming out of the anion exchanger. So water coming out of the anion exchanger, coming out of the anion exchanger. Anion exchanger is neutral. Now we will discuss a percentage of hardness. Percentage of hardness. So we discussed we can calculate temporary. Let us say I have a water. This contains temporary hardness as well as permanent hardness both. So this water contains bicarbonates, also contains, let us say, sulphate or chloride. So this water contains temporary hardness as well as permanent hardness. So we said temporary hardness can be removed by adding calcium hydroxide. So this says we said by adding calcium hydroxide. We also said permanent hardness plus temporary hardness both can be removed by adding baking soda, by adding Na2CO3. So we can say moles of calcium hydroxide. So if I add some mole of calcium hydroxide into this water, it is only removing the temporary hardness, that is moles of calcium hydroxide added is equivalent to temporary hardness, or it is related to temporary hardness. If I add same, if I take the same another sample of the same water and we add Na2CO3, we can say moles of calcium hydroxide, but in this case moles of baking soda, that is Na2CO3 added, is related to temporary hardness plus permanent hardness. So we can, from here we can calculate moles of Na2CO3 minus moles of CaCO3, that is calcium hydroxide, CaOH twice. This is related to permanent hardness. So we can calculate percentage temporary hardness, that is the hardness temporary, divided by temporary hardness plus permanent hardness multiplied by 100, and this is equals to, that is moles of calcium hydroxide divided by moles of, this is Na2CO3, moles of baking soda, and this has to be multiplied by 100. Similarly, we can calculate percentage of permanent hardness, and this is equals to permanent hardness divided by temporary hardness plus permanent hardness multiplied by 100. This is equals to, so if you see permanent hardness, this is moles of Na2CO3, moles of Na2CO3 minus moles of calcium hydroxide, and this divided by moles of Na2CO3 multiplied by 100. So this will give you the percentage of temporary hardness and percentage of permanent hardness. So we can have a calculation. Let us say if I have a 30 ml sample of water, let us say, or 1 liter of water, if I have 1 liter of water, it requires 1 mole of calcium hydroxide or 0.01 mole of calcium hydroxide to remove our temporary hardness, so 0.01 mole of calcium hydroxide, and it requires 0.02 mole of permanent hardness to remove the temporary plus permanent hardness. This requires Na2CO3. So we can in this case calculate percentage of temporary hardness, that is equals to temporary hardness 0.01, this is mole of calcium hydroxide, divided by total 0.02 into 100. So we will have 50%. So 50% is temporary hardness, then permanent hardness is also 50% in this case we have. So equally. So we can always set some numerical problems related to this idea. So let us finish here.